Hello everyone, welcome to this channel. In this video we are talking about von Neumann architecture and why is it so important. So in year 1940s, programming a computer was a physical workout. If you wanted an ENIAC to solve a different math problem, you had to pull out cables and flip hundreds of switches. The program was part of the hardware. In 1945, John Von Neumann proposed a blueprint that changed everything. He asked, why not store the program instructions in the same place where we store the data? This stored program concept is the DNA of almost every computer today. So now let's watch fetch, decode and execute in action to solve a mathematical problem of adding 2 plus 3. So let me explain this to you with an example. Consider this is your memory. This is the instruction area. And this is the data area. Now consider this is our initial setup. Now what we need is basically one control unit, which is this. There's going to be one bus which will fetch data for us. There's going to be one ALU. ALU will also have a temporary location where the output will be stored, and the data bus which again connects back that temporary data into your memory. So now we know the control unit can only do three things. Let me put it here. And this is the current position of what it is about to do. Now the first thing that the control unit will do, fetch the instruction from the memory. The first instruction, which is basically this instruction. This instruction goes on the data bus and comes to this point. Now the second is decode. Decode basically means what to do and from where. So load the data from address 2048. That means 2048 is here. Load this data to here. And since it is load, it is going to be at A section of the ALU. Now execute. That means 2 is going to be stored at register 1 of A. Now second again, fetch. Fetch what? Second instruction, that is add 2049. So add 2049 will basically travel from here and wait here. Then what does it do? Decode. Add whatever is there on 2049 with 2. So the data bus will now get 3 from 2049 and come to 3. So now we know we are going to add, so the control unit will send the signal of add onto OC. So at the execute step, we're going to be adding 2 and 3, and the result of 5 will be saved on the temporary location of the ALU. Now the wheel will move one more time. Fetch. Fetch what? Store 50, the third instruction. It will come and sit here. Then decode. That means understand what to do. Store a value which is there in the temporary location to address 2050. So the operation will be sent by control unit to ALU to transfer this. Now when do we do that? When the execute cycle happens. Then we shift from 5 will go here to 2050. It will sit here. This was the brilliance of von Neumann. He basically shifted all of the complications of the hardware and switching the instructions again and again based on the memory to this idea itself. I think now we understand what von Neumann did. It just didn't build a machine. He built a concept onto which the whole world today is based on. Whenever you download an app, you're basically using that 70-year-old technique which he introduced, and now you're able to do everything without rewiring your hardware every single time. Thank you so much for watching and have a nice day.